Welcome back to EduHub Academia, the Education for a Better Future platform. We will carry on with our course, The World of Physics, lecture number 15, Fluid Mechanics. Now, what is fluid mechanics? It is that branch of physics that explores the behavior of fluids. And with fluids, we mean liquids and gases. It is about everything from the smooth flow of a river, of water in a river, to the powerful thrust of a jet engine. Now we have so many applications in real-world fluid mechanics. It helps engineers design ships that cut efficiently through water, airplanes with aerodynamically shaped wings, and pipelines that efficiently transport fluids, whether gases or liquids. Even our understanding of weather patterns and blood flow within our bodies relies mainly on the principles of fluid mechanics. Now, fluid mechanics can be divided into two branches: the fluid statics and the fluid dynamics. We'll start by explaining the fluid statics. It is about all fluids at rest, and with that come two important concepts. Number one, pressure, which is the force exerted by unit area by a fluid on the walls of a container, although the fluid as a whole is not moving. As an example, you can imagine a glass of water on a table at rest, yet the molecules are constantly in motion, colliding with the glass walls. Now this collision will create a pressure that pushes outwards in all directions. The second concept, which is related to fluid statics, is the buoyancy. It is the ability or tendency of something to float in water or in any other fluid. Buoyancy is related to the force difference experienced by an object submerged in a fluid, which explains why some objects float while others sink. Imagine an object immersed in water or in any other liquid. You can think of two forces acting on the object: its weight, which is downward, which is the pull of gravity, and the buoyant upthrust force, shown here in blue. These two forces are in opposite direction, vertically opposite, and we say that if the weight is equal to or less than the upthrust, it floats. Things that float are buoyant. However, if the weight is greater than the upthrust, buoyant force, the object will sink. Fluid dynamics, on the other hand, deals with fluids in motion, not at rest. Again, we will look at two important concepts in fluid dynamics. The first one is the viscosity, which is the fluid's resistance to flow. If you ever compare the flow of water to the flow of honey, you will find that water is easier to flow from one container into the other because it has a relatively low viscosity, while honey, which has a higher viscosity, will not flow easily from one container into the other. Now, turbulence, on the other hand, arises when a fluid's flow becomes chaotic and irregular. It can significantly affect the behavior of fluids, impacting everything from pipeline flow to airplane wing performance. Now, I want you to imagine a plane suddenly encountering rapid winds, high air pressure, or extreme weathers, like heavy rain. Now, that's turbulence in action. Thank you very much for listening. I look forward to seeing you next time.